So, those were differences in dynamic parameters between obstructive and restrictive diseases. But still, you have other, let's say, procedures with which you can test, for example, in terms of obstructive diseases, if it's only asthma, or if it's asthma or COPD. So, for example, what you can do, you don't know, now he looks like he has asthma or maybe he has COPD. I don't know. So asthma versus COPD. And the thing you can do is you can give them bronchodilators. And what you should remember, you don't know the person, he comes and you don't know. So if you give them bronchodilators, then typically asthma should react to it and you should improve the thing. If it's a COPD, it won't help too much. It's chronically obstructive and you're not able to help him too much, okay? So this is sort of a test through, let's say, drugs for treatment. On the other hand, let's say if someone comes with asthma, maybe he has asthma. You are suspicious he could have asthma, but we don't know. Young person, never diagnosed before. And let's say now he's doing fine because there are no allergens, there are no infections, it's a nice summer, he's feeling fine. But he had this attack and he doesn't know what that was. Well, so in uncertain cases, when you are sort of suspicious for asthma, but now the curves and the spirometry is normal, you can use a provoke test. But this is a pretty dangerous test, so watch out. This should be done in hospitals and you should really watch the patient. But if I'm having asthma, my bronchi will be hyperreactive. And what you can give them is a methacholine challenge test, okay? So, and methacholine is a great provoker. It provokes and increases the reactiveness of the bronchi. So in case I'm going to have asthma, I'm going to react it and I'm going to have a very serious bronchoconstriction. So you give them methacholine, you're going to do a FEV1 test and you should see it there, okay? If it's a healthy person, the person shouldn't react excessively to this, okay? So remember, typically, let's say the worsening of FEV1 is going to be like decreased by 20% if you give them methacholine, okay? Not in healthy person, but in someone who has asthma, okay? So those were so either you give bronchodilators and you will improve the situation in asthmatic patients, not too much in COPD patients, or you can do the provoke tests for asthma, okay? Well, and one more thing is the DLCO, so diffusion capacity of lungs for CO, carbon monoxide, but very low levels, carbon monoxide is toxic, but these are very low concentrations that you can monitor, okay? And DLCO means that you are measuring how much the CO is able to get into the bloodstream, okay? And typically DLCO is decreased. So diffusion is of course decreased in restrictive diseases, the intrapulmonary restrictive diseases. Because if you're, everything over here is about the alveolo-capillary membrane. This is the alveolus, this is the capillary. And if you have a restrictive diseases, the problem is over here. This is getting thicker. There is an inflammation, there's fibrosis going on, and that's why the diffusion of the O2 and CO2 is worse, okay? So it's going to be also worse for CO. Okay. So typically if you have intrapulmonary, so if there's going to be some interstitial fibrosis going on, so interstitial fibrosis, so that means restrictive diseases, but watch out, intrapulmonary diseases. So the process is in the parenchyma. Or even if you have a lung edema, this also, the water then gets over here. So this decreases the diffusion. So in this case, definitely the DLCO is going to be decreased. Yep. So with this, you can tell you're going to do the DLCO and you can tell, hey, this guy has a worsened diffusion, so he very likely has a restrictive disease. Okay, there's some fibrosis, there's some intrapulmonary restriction going on. But you know what? There's one disease that comes from the COPD group and also has a decreased diffusion for CO. But the problem is not in the alveolar capillary membrane. The membrane is totally fine. It's beautiful. There is a very nice diffusion across this membrane. But what could be the problem? Well, the problem is that the membrane is small in total. So we have a decreased surface. Okay? So the important thing what you should understand over here, this is another example. And now the alveolar capillary membrane, it's nice, okay? There is nothing that thickens the membrane. So the passage is okay. But the problem is the membrane, if you count it together, there's not enough of it. So that's why also there's less space for O2 to go through, get to the blood. Okay, so in this case, the surface of all the alveoli is big, but there's a problem in the diffusion through the membrane. But over here, diffusion is fine, but I have a small membrane in total. Okay, and what disease is this one? Where there is it's an obstructive disease, but also I have a decreased surface. Tell me. It's emphysema, because over here the septi are decreased, so that's why you lose the total surface for exchange. Okay, so remember, emphysema is the only disease where there is an obstruction plus decreased DLCO, diffusion capacity. Okay, and if we talk about this like that, then also I'm going to put DLCO in a square over here. But also remember one thing. Also, if you have extrapulmonary restrictive diseases, so you will have decreased total lung capacity, decreased residual volume, decreased vital capacity, plus you're going to have normal DLCO, because the problem is not in the lungs, not in the membrane, but only within the chest wall or whatever, with the control of the lungs, of the diaphragm, okay? So in the extrapulmonary cases, the diffusion is going to be normal as well, okay? Yeah? In this case, in the interstitial fibrotic processes, DLCO is going to be decreased, and also total lung capacity, residual volume, and vital capacity. In case of extrapulmonary ones, it's going to be the same, except the DLCO is going to be normal. Okay? Good. Well, and last is the table. So I'm going to give you examples over here, okay? So this is going to be spirometry, and I'm going to give you 4 examples, A, B, C, D. And I'm going to give you total lung capacity, and over here it's going to be 86%, 56%, 88%, and 53%. Then I'm going to give you vital capacity. That's going to be 95%, 52%, 92%, and 50%. These percents are compared to normal tables, like that the person should have like 100% every time, and now it's somehow decreased or whatever, okay? Yeah. Then residual volume, it's 110%, 51%, 105%, and 50%. Then you're going to have FEF1 in 1 second to forced vital capacity. That's going to be 79%, 95%, 80%, and 92%. And watch out over here. These percents are not according to some standardized tables. Okay, this is a ratio. This is a percentage of the ratio of this actual patient. So it's different than the residual volumes or vital capacity or total lung capacity, because these percents are compared to, like, let's say, expected volumes that you should have according to your weight, height, body surface, and age, okay, or whatever. Okay, but these numbers are real and are specific. These percents are specific to this particular person, because you're comparing the forced expiratory volume for 1 second compared to forced vital capacity of this particular patient, these particular lungs. Okay, so that's what you should understand. And if we go to the next one, then again, it's compared to expected counted percentages, okay? So the next one is DLCO. DLCO, and this is 92%, 90%, 41%, and 40%. And I'm going to give you now 3 minutes, and you try to figure out on your own what could be what on the basis of what we talked about now. You have ideas? Very good. So what do you think? Patient A, what could that be?
Is it asthma?
It's asthma. Very good. It's asthma, exactly. Why is it asthma? Tell me.
The DLCO is normal, so it can't be emphysema, which is the only case it would be.
Yeah, exactly. It was exactly. Very good. So that's asthma. What would be the patient B?
Is it something extrapulmonary?
Very good. So it could be kyphoscoliosis, for example. So extrapulmonary cause. So kyphoscoliosis. What would be the patient C?
Emphysema, because the DLCO.
Amazing. Great. Emphysema. That's emphysema. Very good. Yeah, because the residual volume is increased and DLCO is decreased. Very good. And what about the last one?
Something restrictive.
Yeah, exactly. So it could be, for example, the idiopathic pulmonary fibrosis or something. Yeah. So anything intrapulmonary. So intrapulmonary restrictive disease. Yeah. So we could put IPF, for example. Amazing. So that's it for today. So thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.